It should be on your desk. So let's take a look at these first couple. Gonna work for me? Yeah. So go down the hallway that way. And just pass the bathroom, turn left, and it'll be on the right as you go down that hall. All right. Let's take a look. Problem number 1. I have x squared over x squared. What do they do? Cancel. Good. Y to the negative 3 comes down, so how many y's do I have on bottom then? 8. Y to the 8. Z to the negative 3 moves up, so how many z's are up top? 3. Good. There you go. This is all last chapter, so we're just reviewing. Okay, this one, let's see. That comes here, so that gives me 4. Comes here, that gives me a to the negative 4. Comes there, that's b to the 6. If I go there, that gives me 3 times 3 times 3, which is 27. And then a to the 3rd, b to the 12th. Then I go. What's that? Oh, yeah. If you want. No, it's a times. All right, so then 4 times 27 is 108. Did you make it? Gave up. A to the 4th moves down. If I do a tug of war with the A's, bottom wins by 1. And then B to the 18th. And then, so now, I'm going to show you something that you might get mad at me for. Let's deal with it. Let me show you how the, yeah.
Okay, so, unlike the first question,
yeah.
This is z to like 0. Wouldn't that be like a 1?
Okay, so if you made that z to the 0, 1, then that other one still moves up. Right?
Would it be 1?
All right, now y'all are going to get mad at me. Ready for this? All right, so this is 3 times 10 to the 5th, yes? Divided by 2 times 10 to the negative 2. Ready? So let's close that. All right, first thing I'm going to do, ready? I'm not making it on your calculator. So you go to mode. Turn mode, turn it into scientific, hit enter. Uh-oh. No, I'm just going to show you. Okay, so the first problem is 3 times 10 to the 5th. So you go parentheses 3, you go second e. And it's to the what? To the 10th? Is it to the 10th? So 3e to the 10th on the calculator is the same thing as 3 times 10 to the 10th. Is that right? That's the 5th. Okay, so 3e5 means the exact same thing as 3 times 10 to the 5th. Okay? Divided by 2 times 10 to the negative 2. Okay, divided by 2e, and it was to the negative 2. Oops. To negative 2. Close that.
Oh, I see.
Okay, so the answer to this problem is 1.5 times 10 to the 7th power.
Well, so, Mister, if we want to do it that way, we have to keep switching back and forth from scientific to whatever.
So some of these will work out if they're already big old decimal amounts. Some of them, if I had done that without having that scientific notation, it would have been 1, 5, 0, 0, 0, 0, 0, 0, 0, 0. And then you'd have to say, so don't switch on your calculator to scientific, because if you go to your science and they're asking for another, it's always giving you scientific.
So how do you do it? It won't work.
Well, you go to the mode to do it. Okay, second problem. 8 times 10 to the 2nd. 8 times 10 to the second, so 8e to the second. Oops, wrong button. Close parentheses, and we're timesing it. So open parentheses again. 2 times 10 to the negative 8. 2 second e negative 8. Close parentheses. Second comma. Above the 7 is a comma. Second is very far up left. All right, so this one comes out to 1.6 times 10 to the negative 5. And then the third one, 5 times 10 to the third squared. To the what? Third. And then it's squared. So you do that. Boom. 2 times, or 2.5 times 10 to the 7th. So these calculators will do the work for you, okay? So just notice it is a tool. No. It's the exponential function. So that there's an E key that works on the calculator. So that's just a little insight for that. All right, bless you. Let's move to the next slide. Okay. Classify polynomials based on degree and number of terms. Okay, this is where we're going to call it a monomial, binomial, trinomial, quad, keeps going and going, okay? So an expression of a sum that is ax to the k. So a number with an x, and it's raised to an exponent. So here's some examples. This is not an example. Why is that? Well, it's 1 over x. This is an example. And I know some of these can't see. I believe this says x plus 1, so that's an example. X to the negative 1, that's the same thing as 1 over x, so that doesn't work. 3x to the 4th, no, that's not an example. 9x to the 6th, yep, that works. The square root, no, that doesn't work. And then x to the 3rd minus 4. Those are examples. So x squared plus 3x plus 42. It's in descending order. This says x plus 1, even though you can't see it. This says x to the 3rd minus 4 and 9x to the 6th. Those are all in terms of that. Okay? So it's just you have an x. It's not raised to a negative exponent. It doesn't have a square root. It can have a number attached to the front of it. Okay? I think this next one will clear up a little bit more. Okay, a degree, the exponent term. Okay, so when you have a whole string of exponents, called a polynomial, your highest exponent is the degree, and it doesn't matter does not matter what order it's written in. So let's say we had 3x to the 5th plus 7x to the 6th minus 14x to the 10th plus 6. Okay? Don't let the exponents fear you. If you were to say what degree this is, what's the highest exponent in there? 10. So this is a 10th degree, and then in this case, polynomial. Okay? So it doesn't matter the order it's written in. You just look to the highest exponent. Now, you could rewrite this in standard form, which means you write it in descending order, and you might be quizzed on putting it in descending order. So that says the same thing. It's just I changed the order of how things were written. So the highest exponent refers to what's the degree. Is that okay so far? Everyone happy? Okay. So standard form exponents in decreasing order. So again, just decreasing order. Ax to the k plus bx to the k minus 1 plus cx to the k minus 2. So now you're looking at it going, what the hell does k mean? This could be the same thing as 3x to the 5th plus 2x to the 4th plus 8x to the 3rd. Okay, so descending order are how you put these in standard form. Note the sign before it. So if it's a negative, it's a subtraction problem, it comes with it. If it's addition, it stays with it. Okay, so standard form just means you've rewritten it. You put it in decreasing order as far as the exponents go. The highest exponent tells you what degree polynomial it is. So this would be a 5th degree. In this case, this is called a trinomial because there's 3 terms. But we'll get to name it up here in a little bit. And move forward. Okay, so a constant. What do you think? What's an example of a constant? Yeah, I like it. Just some number. So this is like 3 or 5 or 10. That's a constant. What degree is a constant to? It is, so the degree to this would actually be x to the 0. Because x to the 0, like 95% of y'all got this right on the test, so let's see if you can get it right. X to the 0 is? 1. Okay? So the degree of a constant is to the 0 power. And so your examples are like 5 and 18 and -6 and 2. Okay? Those are constants. It's just a numeric value. It doesn't have a letter attached to it. If it is linear, and I graph it, it would make a straight line. Everyone okay with that? So linear is x to the 1st power, so it's the 1st degree. An example of linear would be like x plus 2. It might be 5x minus 3. It could be just, I don't know, 7x. Okay? Those are linear, meaning my highest exponent in my entire problem is to the 1st power. And if I were to graph it, if it was asked to graph it, it would form a straight line. Is that okay so far? So constant are just numbers. Linear, your highest exponent, no matter how many of them there are, the highest exponent is x to the 1st. Okay? And x to the 1st can be just written as x, yes? Okay. A quadratic is x squared. Okay? Your highest exponent is squared. So your degree is a 2nd degree. So you could come across it like this. X squared plus 5. You could come across like 3x squared minus 5x plus 2. You could even have 2x squared. Okay? X squared is your highest exponent. It means it's quadratic. A quadratic is something called a parabola. A parabola equation or a quadratic equation, you all have been involved in many situations that have dealt with this. Okay? You ever ride in the car and someone hits the brakes real hard?
Yeah.
Stopping distance is a quadratic function. You ever jump off like the roof of your house from the 1st floor to the ground? The acceleration of gravity is a quadratic. So the further you jump, the harder you head, right? And yes, I understand. Well, what about terminal velocity? If you jump off your roof of your house, I don't care if it's a 3-story house, you're going to hit terminal velocity. You're going to break a lot of stuff. You go off much more than the 1st floor. Okay, cubic. What do you think? Cubed. Highest exponent. X to the 3rd. Yeah, x to the 3rd. So it's a third degree. So cubics are like x to the 3rd plus 2x squared plus 7x plus 5. Or I could just have 3x to the 3rd or 5x to the 3rd or something like that.
Would that also be a quadratic?
No, because the highest degree has to be a 3rd. So I have x to the 3rd. Quadratic highest degree is 2nd.
Oh, quadrant. Oh.
Quartic. Anyone want to take a short at quartic? X to the 4th, yeah. So x to the 4th, so it's a 4th degree. And so you could just have something huge. You could have, 7x to the 4th plus 5x to the 3rd plus x squared plus 2x minus 6. X to the 4th. Ooh, that's big stuff. Quartic. Okay, so constant, linear, quadratic, cubic, and quartic. You want to keep going. The next one's called quintic. No. You'll learn those when you take organic chemistry in college. You start naming, different organic compounds. And those you're like, dude, it's organic. Yeah, you know what organic means? It contains carbon. So it's like, oh, you should eat this. It's organic. Of course it is. It's got carbon in it. I didn't eat no carbon. I tell you this, it's good for you. It's organic. It's got carbon in it. You want to know what else is organic and has carbon in it? Gasoline. So when someone says, dude, it's organic, you can eat it. When you ingest gasoline, I'll tell you what. You either get violently ill or you will die, right? So when people say, it's good for you, it's organic, just letting you know, there are organic compounds out there that are really bad for you. All right, a monomial. Mono means one. A binomial means two. Bicycle, two. Trinomial means three. Okay, so a monomial, you could have something like this. You could have 5x to the 6th power. Okay, it's a 6th degree, but it's a monomial because there's only one term. You could have x as a monomial. You could have 3x as a monomial. Those are all examples. Constant, yeah, you could have like 3. That's a monomial. Good call. Or 10 or 7 or whatever number. A binomial means there's 2 terms to it. They're either being added or subtracted. So you could have x plus 10. That's a binomial. There's 2 terms. There's an x term. X is raised to the first, so it's linear, and a 10. Okay? You could also have x squared minus 6. There's 2 terms there. It's a binomial. And a trinomial, just to follow suit, would probably have how many terms? 3. So you have 3x squared plus 2x minus 6. You can change your exponents, whatever you want. If you have 3 terms separated by addition or subtraction signs or combination, it becomes a trinomial. The leading coefficient, you look wherever your highest exponent is. And the base number is your leading coefficient. That stands for number. I know it's hashtag in your guys' lingo. Okay, it's also called the pound sign. All right, so leading coefficient, if I had some problem like 5x to the 3rd plus 7x to the 4th plus 10, what's my highest exponent in there? The 4th, so it's 4th degree. What's that leading coefficient on that 4th degree? 7. So this would be my leading coefficient if I wrote this in descending order, standard form.
That'll be your least coefficient.
You look for your highest exponent, and then you're looking for your leading coefficient. What's that? The leading coefficient, what it really does to your graph, later in math when you start graphing these and you start looking at these really wackadoodle looking graphs, that leading coefficient, as it gets to be a larger and larger number, means your graph becomes more and more straight up and down. As that becomes negative, it just flips it over the y-axis. As it becomes a fraction between 0 and 1, it means it gets really fat. Okay, but that's just added bonus information for later days. Is everybody okay? Is everyone thing that I'm covering okay? So we're just naming things so far. So you can have a monomial, binomial, trinomial. You have a constant term. A constant is just a number. You can have their degrees. First, linear is 1st degree, quadratic 2nd degree. 3rd degree was what? It was on your paper? Trinomial. 4th degree was a. So we have quadratic is x to the 3rd is cubic and quartic. So those are just some of the names that we have. So we have to make sure we go back to those. All right. So let's take a look. 7x plus 4. What degree is 7x plus 4? What degree is this? What's the highest exponent? What's the highest degree? 1. Second problem. What's the highest degree on the second one? 2. What's the highest degree on the 3rd problem? What's the highest degree on the 4th problem? This doesn't have a letter there, so it's 0 because you'd have x to the 0, right? And then last one is out of order, so what's the highest degree? 3. So let's just pause there. Make sure you understand why those work the way they do. Anything goofy about those that we need to cover a little bit different? Okay? What's the next thing say? Name using the degree. Okay, hang on, I gotta flip back. Name using the degree. I'm gonna name it with the degree. Oh, I'm gonna name it constant, linear, quadratic, cubic, or quartic. Constant, it's to 0 power. Okay, so constant, linear, quadratic, or quartic. Okay, so it's the first one. Linear. The second one. Quadratic. I'm just going to call it quad. Is that okay? The third one. Cubic. It's to the third, right? Next one. Quartic. Quartic. What's this one? It's a constant. We're going to go through them enough that I bet you they'll start grabbing on pretty good. Last one's what? Degree.
Oh no, cubic.
Cubic, yes. Good call. Number of terms. Okay, so number of terms. How many terms are right here? 2. How many terms are here? 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 How many are here? Okay. So name number of terms. Okay, so that was back here. Monomial, binomial, or trinomial. Okay. First one is 2 terms. Binomial. This one is trinomial. What's this one? Monomial. What's this one? Binomial. What's this one? Monomial. What's this one? Trinomial. Okay. What's my leading coefficient on the first one? 7. Leading coefficient on the next one? Leading coefficient on the next one? Leading coefficient? Highest exponent is what? Highest exponent. 4. Leading coefficient of that exponent is? 9. What is this one? Just 5. Leading coefficient there? Careful.
2.
Careful. -2. See that? You got to make sure you bring that into plane, okay? Woo!
So,
Yeah.
leading coefficient is the number that the highest exponent is related to?
Yes. So you look for the highest exponent, whatever the base of that would be, next to the x. That would be, and it could be negative as well, as we just saw in that last one. How are we doing so far? Life good? Where am I at? Okay, Oh man, dude, we are rocking and a rolling. Any questions so far? Now, you ready for the? Ready for that? This, you don't have to know this, but this is what's really cool. Okay? So as you talk about the degree, which is the highest exponent, yes? Let's say you have like x to the 16th power. Still with me? That means you're talking about something that is happening in the 16th dimension. Let's say I have a highest exponent of 20. That means you're talking about something that's happening in the 20th dimension. Let's say you had just x to the first power. You're talking about something that happens in the first dimension. Let's say you talk about something that's raised to the 0 power. You're talking about something in the 0 dimension. Okay, when I talk dimensions, you're like, well, I know like length, width, and height. I know. So far, I've heard that up to 13 dimensions have been defined mathematically and scientifically. but mathematically we can go really to infinite dimensions. Ooh, that's a little different. Kind of weird, huh? Okay, back to our story. All right, adding polynomials. The first thing I need to look at, is there anything out front here that I have to distribute over this parentheses? Nope, so I'm just going to rewrite this as this. Is there anything to distribute over this? I'm not sure what you're looking at, but okay. So now we need to combine like terms, and a like term means you have the same letter and exponent. Okay, so I have 2x squared and I have an x squared. So how many x squareds am I adding together? What's the number here? 1. Plus 2 is 3x squared. Okay, now let's look at, I have an x and I have an x. How many x's do I have? 2x. And then I have this and this. So I get a what? Plus 1, good. Hey, is this in descending order? It is, so it's in standard form. So this is a second degree. Is that all right? Leading coefficient of 3. Trinomial. It's a quadratic because its highest degree is 2. All right, so next one, let's see. I have 5x to the third, that's going to write down, plus 2x squared, minus 3x plus 6. Is there anything for me to distribute over these parentheses? No, let's just be cautious we keep the sign. So I get plus 8x to the third, minus 4x squared, plus 12x, minus 5. Does it appear we might have like terms? Remember, a like term is the same letter and exponent. So I have, there is none? Let's see, 5x to the third and 8x to the third. Same letter, same exponent. Add them up. 13x to the third. Good. What else? We got what? Wait, hang on. 2x here and here.
Oh, it's negative 6.
2 minus 4 is?
Oh, 2 minus 4.
Negative 2x squared, right? And I have here, negative 3 added to 12.
Say it again.
Negative 3 applied to 12. 9. 9x. And then 6 added to negative 5. 1. So that is a third degree. There's 4 terms. Wow. It's cubic. Am I done? Or is there one more?
There's something back.
Someone back? All right. Ooh, find the perimeter. Hey, how do I find the perimeter of something? Add up all the sides. Okay. So I have x squared plus x squared, 2x squared. Still with me? So those are like terms. And then I have a 3x and a 2x. That's a 5x. And I have a negative 10, a negative 2, and a 12. Negative 10 and negative 2 is negative 12. Negative 12 plus 12 is 0. This is my perimeter. That's all it is.
Wait, you explain how you got right here?
How do I get the perimeter? Just added up all 3 sides. So I add x squared plus x squared is 2x squared. Right? And then I had a 2x and a 3x. So if I add those together, I get 5x. And then negative 10 minus 2 is negative 12. Negative 12 plus 12 is 12. All right. So, ladies and gentlemen, page 39 and 40 is your homework. Now, I want to relay this, and I put this on a lot of the postcards. And actually, there's only stuff on page 39. Page 40 is blank. But I want to relay this information to you, and I want you to think about this. I want you to strongly consider this. If you're kind of like, you know what, my homework in math sucks, I find that when Mr. Stroop gave me a top mark that I've gone through and I had to change almost every answer that he worked on, that means that maybe let's try something new. So I want to offer the opportunity to you all that if you want to ever come in before school, Monday through Thursday, I am in my office, West 439A. That's just down the hall. Yeah, if you get here at 1:45, it's plenty of time. Bring breakfast if you want. If we get too many people in there, we'll just meet in a classroom. Okay? But if your homework is kind of getting cruddy and your understanding is kind of getting cruddy, maybe if you change something up and you wanted to try this from time to time. Okay?
All right, Mr.
That's all I have for you. Don't leave yet because you still got about